Hey there, thanks for watching. This is part 6 of a 6-part series on text mining. It was originally a 5-part series, but this video answers some questions that some people had about the last step. So in this video, I read some documents from folders, process them with the process documents from files operator. Okay, turn them into lowercase that you can match up the same words that have different cases. Tokenize them, which means split a document into its various words. Filter out stop words, which are overly common words such as and the, and aren't very good discriminators, and just add extra columns. And stemming, which gets rid of the suffixes of words, so you can make computerized or computerize all the same word and count them the same. And then generate n-grams. I tried a few different ones, but it turns out that unigrams are the best in this case here. Okay, use cross-validation to get the error rate range. Okay, this one I'm using a support vector machine, but you can use any classifier really. Apply the model, test the performance. Okay, so I'm just going to look at the data here. So I got 3 folders, classifying between 2 of them. Okay, so one are some healthcare related jobs from Craigslist, certified dental assistant, home care provider. Okay, those are in a folder called healthcare. And there's 30 other jobs that aren't healthcare related. So there's a truck dispatcher, finance professional. Okay. So this folder, or this operator, you tell the text directories you're using, and then you give that a label. So this will be the healthcare label, and this will be the not healthcare label. We're going to try to discriminate between those two. Okay, so I'm just going to run that. Okay, we get about 82% accuracy, 83% precision, which isn't bad for only 30 documents of each class. I'm using the TF-IDF vector in this regard. You can check video 4 to see how that works. You want to make sure the add meta information is checked so that it passes the labels through the process documents operator. Okay, I'm also dropping the 5% least common words, just so there's not too many columns. Okay, and depending on your system, you either want star or star.star as your file pattern. If your files are HTML, you can check extract text only, but these ones are plain text. Okay, and this one doesn't really matter. But you do want to create a word vector. You can keep the text or not, doesn't really matter. Okay, now to use this model, this support vector machine or any classifier on a new document, and you want to classify that new document, you need to do a couple things. First, you need to store the word list. Okay, so this one creates a word list, which basically counts the frequencies of the words in the documents. Okay, so just use the store operator, and then give it a name word list, and it'll store that word list in the repository. Okay, we'll use that later. And then after cross-validation, you want to store the model, because that's the model that you built that's learned how to discriminate between documents based on the frequencies of words. Okay, so I use the store operator and then store the model in the repository as well. Okay, so if you check the repository, it's got the word list and the model there, because I just ran that. Okay, so now I'm going to disable these guys here and enable these other guys. Okay, so now I'm reading the word list that I saved previously up here. Okay, because the model needs the exact same words as before. Okay, process documents, it's the same operators up here. Okay, but I'm reading a different folder, so I'm reading the unknown folder and labeling it unknown. But it's got the exact same settings, which is necessary. Okay, so extract text is off, use file extension as type, TF-IDF, add meta information, 5%, drop the 5% fewest words. Okay, and it's got the same internal operators as well. So transform case lowercase, tokenize on non-letters, filter stop words, stem, generate 1 grams. Okay, so you need the same word list as you made before. You need the exact same process documents operator, although on different data. Okay, and you need to use the same model as used before, so I'm using get model to grab that model. Then you're going to apply the old model that you learned, okay, on the new data. Okay, so that goes into the model section of apply model, and then the data goes in here, and then it's going to give you the predictions outside the label one. Okay, so that unlabeled data, or unknown data, is 12 documents. About half of them are healthcare related and half aren't. Okay, I'm just going to run that. Okay, now it doesn't give us a performance because it doesn't actually know what the predictions are. Okay, but it doesn't know what the correct labels are, but it does give you the predictions. So we got 6 or 7 not healthcare and 5 healthcare predictions. Okay, in the actual data, that's not healthcare, executive assistant not healthcare, purchaser not healthcare, food service not healthcare, special effects not healthcare, experienced painter not healthcare. Okay, and then these next 6 are healthcare ones: healthcare assistant, dental receptionist, associate dentist, registered nurse, caregiver, and then cook. This is the one that actually gets wrong. It's all about being a cook, not super healthcare related. It mentions the word healthcare in here as well, but it doesn't have enough words in this document so that it can discriminate and know that it's a healthcare related document, because it could pretty easily be just a kitchen job, right? Okay, so yeah, got these 6 right and got 5 out of 6 right on this side. Okay, so you could use that in a variety of applications. You could use sentiment analysis, or look at stock prices, or see which grant applications are more likely to succeed, and stuff like that. Okay, so that's how you save your word list and model, and then apply them later on data that the model hasn't seen before. Okay, thanks much.